In the previous video we were doing counting functions, and in this video we're going to do counting injective or one-to-one functions. Okay, so let's just have a quick look at the difference. Just as a reminder, a function, every element in the input, which is here, has to match with exactly one element in the output or the codomain here. With an injective or one-to-one function, every element in the input has to match with a distinct element in the output, and that is the difference. So let's just take an example. For example, 1 2 3 to 1 2 3 4 5. So basically, if it was a function, we could have this. That would be a perfectly acceptable function where they all map to 1. That is not an injective function. We can't have that because they have to map to distinct elements. So for example, an injective function would have to be something along the lines of that. Now, how many injective functions are there? Well, if there's no restriction whatsoever, and this here has n elements and this here has m elements, well then the number of injective functions is n factorial over n minus m factorial. And just taking this one example here, well, there are 3 elements here and there are 5 elements here. So basically this one can choose any of those 5, this one therefore can choose any of 4, and this one can choose 3, so that would be 5 times 4 times 3, which equals 60, or another way of writing it is NPM. Okay, now unfortunately in most college entrance tests there are restrictions or constraints which make the the calculations more complicated. So let's have a look at a couple. Okay, here's the first one. Pause the video if you so desire. Okay, right, so the number of one-to-one or injective functions from here, the domain f, a, b, c and d, to the codomain 0, 1, 2, 3, 4 to 10, such that we have this constraint here, 2fa minus fb add 3fc add fd equals 0. Okay, well the first thing we want to do is just amend this. I like to rewrite it so that the biggest number is at the beginning, and so there are no negatives. So basically we have that. All I've done is I've just rearranged it so that we have 3fc add 2fa add fd equals fb. Okay, now what we're going to do is we're going to draw a table. We literally do count these, so let's imagine that c maps to here, and I'll write in a different colour, and then this will be 3 times f of c, and then let's see what a can possibly map to, and then we have 2 times f of a, and then we have f of d and f of b, and then here we can have the number of possible injective functions, which we will then add up. Okay, so let's have a look. Let's try and keep that in. So that's 3fc out. Right, so basically f of c, let's write it in a different colour. This is what it will map to. What colour shall I write it in? Let's write it in blue. Okay, so f of c, well of course f of c could map to 0. F of c could also map to 1. F of c could map to 2, and f of c could map to 3. It can't map any higher than that, because if f of c mapped to 4, for example, then 3 times f of c would already be 12, and f of b can only possibly go between 0 and 10, because that's what the codomain is. So we know that it can't be any higher than that. And for each of these numbers, so let's just draw a little bit of a table here. And there's 1, let's separate that, and here's 2, let's separate that, and then there's 3 down below. So where fc equals 0, obviously, let's just change the colour again. 3 times fc here would be 0, 3 times fc here would be 3, 3 times fc here would be 6, and 3 times fc here would be 9. I'm only writing them in different colours so we don't get confused. Now a could be mapped to, well, it could be mapped to 1, 2, 3 or 4. Note it cannot be mapped to 0 because it's an injective function, and c is mapped to 0, so a can't also be mapped to 0. That's the difference between an injective and not an injective function. So it could be 1, 2, 3 or 4. It can't be greater because, as we see, when we have 2 times f of a, that will be 2, 4, 6 and 8. Well, if we had here 5, well that would be 10. Well, obviously clearly we can't have this equation satisfied if that bit alone is 10. Okay, so that's if it equals 1. So let's have a look. So basically if f of c is 0 and f of a is 1, well then 3 times f of c add 2 times f of a is 0 add 2. Well, that means that f of d could be anything of, it could be 2, 3, 4, 5, 6, 7 or 8, and therefore f of b could be 4, 5, 6, 7, 8, 9 or 10. And that is basically 7 possibilities. So let's put the number of possibilities in red. There's 7 possibilities there. Okay, now let's go to the second line where f of c is 0, so 3 times f of c is 0, and now let's let f of a be 2, so 2 times f of a is 4. Well, therefore, we know that f of d could map to 1. It can't map to 2 because a is mapping to 2 and it's an injective function, so it can't map to 2, 3, 4, 5 or 6, which means that b would map to 5, 7, 8, 9 or 10, which is 5 functions. So let's put in here 5 more possibles. Okay, let's have a look when f of c is 0, when c maps to 0 and a maps to 3. Well, that means that 3f of c add 2f of a would be 6. Okay, so now the d could map to either 1, 2, it can't map to 3 because 3's there. And by the way, it can't map to 0 either. Neither of these can map to 0 because c is mapping to 0. So it can't map to 3, or it could map to 4, and therefore b would map to 7, 8 or 10. Well, that's 3 more. So we add 3 more there. And then finally, f of c equals 0 and f of a equals 4. So 2 times f of a equals 8. Therefore, d could be 1 or 2. Again, it can't be 0 because 0 is already being used by c, and it can't be anything higher than 2 because otherwise the equation won't work. Remember, b can only be between 0 and 10, and that would be b would be 9 or 10, and that gives us another 2. Okay, so that's all of the possibilities for when c is 0. Okay, so let's move on to when c is 1. So if c is 1, therefore 3 times f of c is 3. So basically f of a could be 0. It can't be 1 because c is mapped to 1. It could be 2 or it could be 3. Okay, so that means that 2 times that would be 0, 4 or 6. And so therefore on our equation that means that this one here, this is d, isn't it? That's f of d. And this here is f of b. So that means d could be mapped to 3, 4, 5, 6 or 7. Or 2. So it could be mapped to 2, 3, 4, 5, 6 or 7, and that means that b could be mapped to 5, 6, 7, 8, 9 or 10, which means there is another 6 possibles there. Let's have a look at the next one. So therefore we have this is, sorry that the headings have gone off the top of the screen, apologies for that. So therefore we have c is 1, so that means 3 times f of c is 3, and that is 2, so that would be 7, which means that therefore f of d could map to 0 or 3, which means that b would map to 7 or 10, so that's 2 more. And basically all you're doing here is just going through one by one, and seeing what maps and what doesn't map. So the last one here would be, if that is 3 and that is 6, well clearly that means that the only thing that d could map to is 0. Note it can't map to 1 because 1 is already being used by 3 and it's an injective function, which means that this would be 9, which is 1 more. And then finally, then we have 2. Let's try and keep those titles in. So if c maps to 2 here, then a could map to 0 or 1. It can't map to 2, obviously, because c maps to 2. And so therefore 2 times it would be 0 and, oh sorry, that should be in black, 0 and 2. Okay, so therefore we could have d could map, that's 2 times, that's 6 at 0. D could map to 1, 3 or 4. It can't map to 0 and it can't map to 2 because they're both taken, which would mean that B would map to 7, 9 or 10, which is another 3. And then finally down here, if C is 2 and A is 1, that means that the only thing that D could be is 0. It can't be 1 and it can't be 2 because they're already taken, which would mean that B would be 8, and so there's one more there. And then finally, if C is equal to 3, then A can only be 0. It can't be greater than 0, and so therefore 2 times A would be 0, and therefore the only thing that D could be is 1, which means the only thing B could be is 10, so there's one more there. And all we have to do now is just add those up. So that is 7 add 5, add 3, add 2, add 6, add 2, add 1, add 3, add 1, add 1, gives us 31. So the answer is 31. That is the number of injective functions that satisfy this constraint here. It is fiddly, and the problem is more whether or not you can do it in the time given, rather than whether or not you can do it. It's just a question of being very careful. Okay, well, let's have a look at the second question. Here's the second question here. Pause the video if you so desire. Okay, so we have the probability that a randomly chosen one-to-one injective function from A, B, C, D to 1, 2, 3, 4, 5 satisfies this constraint here. Okay, and these are the 4 probabilities that we've got. All right, so basically, let's imagine that there was no constraint. Then basically we have here the set is 4 elements, and here the set has 5 elements, and so therefore the number of possible injective functions given no constraint is 5p4, which equals 5 factorial over 1 factorial, which equals 120. So that's how many possible bijective functions there are, and in order to find out the probability that it satisfies that, we have to find out how many satisfy this constraint and then divide it by 120. Okay, so let's have a look. Again, let's put the numbers in blue. So let's imagine that, sorry, let's go back to that. Let's imagine here that we have, well, first of all, we've got to rearrange this. So 2f of b, remember, put the biggest one at the beginning, add f of a, and basically never have a minus sign. It's always miles more difficult if you've got minus signs, so always make sure that everything is a plus. So that is our constraint, just rewritten. Okay, so let's have a look. If we have f of b here, and here we have 2f of b, and here we have f of a, and then here we will have f of d. It's going to be the same table as before, f of c, and then we'll have the number of possibles. Okay, so let's imagine that f of b is 1, so that's what b would map to. Okay, so then 2f of b would be 2. Okay, well, f of a could be, well, it can't be 1, but it could be 2, 3, 4, or 5. So let's have a look. If f of b is 1, then 2 times f of b is 2, add f of a is 3. Well, we can't find an f of a, f of d plus f of c where their sum is 3, given that they're not allowed to be 1 and 2, because it's an injective function. So there is 0 there that work on there. What about for it equal to 3? Well, 2 times f of b would be 2, add 3 would be 5, so we need to find f of d, add f of c, which equals 5, given that it can't be 1 and 3, and there isn't 1, so we can't have it there. What about 4? Again, so that would have to be, f of d add f of c would have to equal 6. Well, clearly that can't happen. And then the final one, we would have 2 add 5. Well, 2 add 5 is 7, and we can make 7. Could be 3 and 4. So f of d could be 3 and 4, or 4 and 3. So there we have 2 possibles. Okay, so let's have a look at what about f equals 2. F of b is 2. Well, therefore 2f of b is 4. And let's have a look at what f of a could be. F of a could be, 1, 3, 4, or 5. It can't be 2, obviously, because it's an injective function. And we will find that by going through exactly the same process that we just have, basically we could only have it when 2 of fb is 4, and f of a is 4. 4 plus 4 is 8, and that would allow these to be 5 and 3, or 3 and 5. For these two numbers and this number here, we cannot have any, because there are 0 possibilities that satisfy this constraint. So that is another 2. and then when equals 3, f of b equals 3, we have 2f of b equals, sorry, wrong colour. We have 2f of b equals 6. Remember, the blue is the numbers it can map to, and the black is the numbers to put into the formulae. So basically, a could be 1, 2, 4, or 5, and the only one of those which maps to anything is if it equals 1, which will be 5 and 2 and 2 and 5, and so there will be another 2 there. And finally, for if f of b equals 4 or f of b equals 5, then we will get here 2 times 4, 8, and 2 times 5 is 10. Well, we cannot find any A, D, or C which satisfy this equation where B is 4 or 5. So the total number that we can find is equal to the sum of these, which is 6. And so therefore the probability, which is what it asks us, the probability that are randomly chosen is equal to 6 over the total number of injective functions, which is 120, which is equal to 1 over 20, which equals option D. They are quite fiddly, these. They're not difficult, but you just have to basically find a way where you can make a table in a way like this, so that you can count all of the different possible injective functions, and you have to find a way to do that quickly. Well, I hope you found this useful. What we're going to do in the next video is counting bijective functions, and the video after that, surjective or onto functions, and they both have their own idiosyncrasies. So I hope you enjoyed this. Please like it if you did, and subscribe to the Gresti YouTube channel. Thank you.